Welcome back, Life Sciences. I hope you enjoyed that break. As I always say, just get the blood flowing, get the oxygen going. It makes us more productive rather than sitting there and just taking everything in. We're looking at this whole concept of gaseous exchange, all right? And when we look at gaseous exchange, the lessons that we've looked at, we actually looked at how gaseous exchange works. And that is where we exchange gases over a surface area at both the lung and the tissue area. But now we're going to come back to the concept of breathing again. And breathing is when we take air in. It's the physical process. Remember when we looked at breathing, what was involved? Our diaphragm, the muscles that moved down, and our intercostal muscles that moved out with our rib cage so that we could make the space. So because remember, our lungs don't have muscles in it. So we rely on the diaphragm and we rely on the intercostal muscles to be able to give us space. Now we're going to look at quite a different concept now, is how, I wonder if you've ever thought, how much air do I have in my lungs? How much air, all right, do I breathe in and how much air do I breathe out? Now again, always there's a few terms that might be new to you. Make sure you understand those terms. Make sure you know where to use them, all right? Always life science is a different language and you must be able to speak it. Now I don't know if any of you have ever had to have a breathing test, right? And basically what it means is you've got this little machine, right? It's called a spirometer. And what it tests is your lung volume. What do I mean by lung volume? It's basically how much air I can take into my lungs. And it's to see if your lungs are actually healthy. Sometimes when you're sick or you've had some kind of disease, you actually decrease the chances of you going to your lungs. So what I want you to have a look today is this whole concept of how much air do we breathe in and how much do we breathe out? All right, so guys, if we look at this spirometer, you will see over here, it's a tube, all right, linked to where we can put air in. And what you don't see, it's linked to a bit of a computer screen. Now, I've had to do one when I was much younger. I decided to go on a diving course, and I had to go and have my lungs tested because if I wanted to go and dive underwater, right, I obviously had to make sure that my ears were in good condition and that my lungs were able to take in this oxygen because remember, we can't breathe underwater, so I needed a tank. So what the spirometer does is you almost hyperventilate. You've got to take in as much oxygen as you can. So you have this huge big breath, you fill your lungs, and then what you have to do is you have to breathe almost everything out. And you cannot stop breathing out until literally everything air that you have right is gone. It's terrible. Okay, now obviously guys, with COVID, a lot of people are using this machine because COVID is attacking the lungs and they need to see, all right, how are they breathing? What air are they taking in, etc. Now I want to show you this graph. So what happens is most people, all right, most people have approximately 5 to 6 liters of air capacity in their lungs, right? So your lungs have this capacity to fill up, right, with at least about 5 to 6 liters. This was the part I was talking about in the beginning, was this tidal volume. And what tidal volume is you can have a look. This is your quiet breathing every single time you breathe in through your nose and out. And if you have a look at the pattern, all right, half a liter comes in, half a liter goes out, half a liter comes in. Now, all of a sudden, now that's why I say to you, you breathe in normally, and now with this machine, they ask you to take this huge big breath, and then they ask you to take it out. Now, this curve over here, all right, this curve over here is basically what they call your inspiratory reserve volume. And what they mean is you are breathing in the 1/2 liter constantly, okay? You will at times need, as we looked at homeostasis, there will be times when your body will need more oxygen and take out more carbon dioxide. It's not going to look like this as much as this. This is usually, remember I said to you, if I take a breathe out, maybe your teacher made you do it in class. I know I sometimes, right, if you got a tank of water, I asked them to take a deep breath and I let them blow through a tube, and they've got to see how the water rises. Most people can breathe out approximately 2.5 to 3 liters. I did notice that the pupils that are fitter in my class, that are more sporty, actually can take out about 4 liters. So they're able to use a lot, and that actually goes to your fitness, etc., being able to bring in more air so that you are able to exercise more. Now I want you to have a look at this bottom one over here. Guys, your lungs cannot deflate. What do I mean by that is that you need to have approximately 1.5 liters in your lungs at any time. So what happens is, you've often seen, right, in the movies, somebody gets stabbed in the chest. Now remember, if I look at my thoracic cavity like that, how did I breathe? Everything was about air pressure. So as soon as if I get stabbed or something happens, what happens if I got a hole, somewhere gets happening is over there, what happens to the pressure? It deflates. And literally, my lungs actually start to deflate like a balloon. And when that starts to deflate, right, my lung collapses. It's called a pneumothorax. And my lung actually collapses, and I'm not going to get the air in. I've got to try and get the air. My lungs need to inflate again. So remember, as I said, your lungs don't totally deflate and then inflate. There's this residual volume with the lungs being all the time. Now I've put a little bit of a picture on, a bit of a question on the board here for you. And it says, Stacey's training for a marathon. She uses a spirometer, so she's found how many breaths, to find out her breathing rate and the volume of air that moves in and out with every breath. Right, so this is Stacey's breathing rate at rest. Can you see there? If we have a look over there, and this is what happens to her breathing rate when she exercises. Obviously, when we exercise, we looked at the concept just now, I need more oxygen in because I need to get more carbon dioxide out. All right, guys, if we have a look at this multiple choice question, the question says, how much more air did Stacey take in per breath whilst exercising than at rest? So let's have a look at her graph, all right? So if we put in here 2,500, right, how much was she taking in each time? The 500s. That's pretty much what we said, which was normal. Now, if we have a look here, we can see these lines are much greater volume. Which would we expect when she is exercising? So if this is 2,500, all right, this is now 3,000. This would be 3,500. How much more? Right, so this is the more. So if I look at do my maths, 2,500 to 3,500, I'm hoping that one of my answers is going to be 1,000 centimeter cubed. And I go through it. A is 500. I know it's not. B is 1,000. I say, whew, thank heavens, that is my answer. And my maths is not so bad. Right, the next question, after a few minutes of exercise, Stacey's legs began to ache. For the reason for this is because, now you see guys, we can link it to a different section. And why would her legs begin to ache? She's not getting enough oxygen. Cellular respiration, all right, is turning to anaerobic respiration. And she is producing, number B, far more lactic acid. Right, the last question in this series. The spirometer trace shows that Stacy breathed more quickly and deeply during exercise than she did at rest. This is because working muscles need extra oxygen to release more what? What is the process where we take in oxygen? What do we want to release? We want to release energy, all right? That is what she needs. She needs the energy, and that will be number A. Okay, guys, that's all we have time for now. We're going to take a quick break, and we'll be right back.